Hello everyone. This is a GCSE revision video of a series where I discuss past papers and model questions every week to prep for exams. Many of these questions are relevant for high school maths qualifications around the world, like O-levels, AP and SSC. For detailed explanation, I have made topic-based theory and question videos. You can check them out on my channel. Here you have a solid cone. Read the question carefully. You have all information on the diagram. What they ask you to do, you have to work out curved surface area of the cone that is not painted gray. This surface area in white. And you have to give your answer as a multiple of pi. You must show your working. You can use this area formula of a cone, A equal to pi RL. L is the slant length. You can work out curved surface area not in gray if you know the surface area of this little cone and surface area of this large cone. So you can write required area equal to curved surface area of large cone minus curved surface area of a small cone. Take this small cone. To work out curved surface area, we need to know the radius of this curve and slant side length that you can find if you take away 10 from 25. This length is 15 centimeters. We don't know that radius. I'm going to take that as R. Let's see how we can find that R. I'm going to draw this line. It's the perpendicular height of this cone, and here this radius is 10 centimeters. How we can find this radius R? If you take this large triangle and this is small triangle, they are similar triangles. Therefore, both of these triangles have same linear scalar factor. Therefore, if you divide this length by this length, is same as if you divide this length by this length. So you can write R divided by 10 should be equal to 15 divided by 25. Simplify this, you would get R equal to 6. Now you can find curved surface area of large cone. It's given by pi RL. R is 10, L is 25. This is equal to 255. Now you can find curved surface area of a small cone. That's again given by pi RL. We found R as 6 times L is 15. This equal to 90 pi. Therefore, required surface area equal to 250 pi minus 90 pi. That's equal to 160 pi. You have to solve this quadratic equation by completing the square method. When you solve quadratic equation by completing the square method, you have to convert quadratic equation into this form. X plus or minus a square equal to b. Important, coefficient of x must be 1. A and b are constant. When you have middle term negative, you would get x minus a inside the bracket. If you have plus sign here, you would get x plus a. Now let's see how we can convert this equation into this form. First step, you need to move this negative 7 to the right hand side. To write complete square on the left hand side, you have to have coefficient of x square as 1. Here we have 3 as the coefficient of x square. Therefore, first we need to get rid of this constant 3. How you can do that? You can divide whole equation by 3. That would give you x square minus 2 over 3x equal to 7 over 3. Next step is important. Coefficient of x. You have to take half of that. That's 1 over 3. Then you have to add square of this number to the both sides. That's x square minus 2 over 3x plus 1 over 3 square equal to 7 over 3 plus 1 over 3 square. Now you have complete square on the left hand side, that is x minus 1 over 3 square. On the right hand side, you have 7 over 3 plus square of 1 over 3 is 1 over 9. You can simplify right hand side, make 9 as the common denominator. You would get 22 over 9 on the right hand side. Now you have this form here. To solve this equation, you have to take a square root to the both sides. Don't forget to write plus or minus. You can split this into two equations, positive value or negative value. You can solve these two linear equations now. X equal to 1 plus square root 22 over 3. Or this one gives you x equal to 1 minus square root 22 over 3. You can use the calculator to find these two values and give the answer correct to two decimal places. Here you would get x equal 1.9 correct to two decimal places. And the other solution you would get minus 1.23 correct to two decimal places. Part A, they ask you to express this expression as a single fraction in its simplest form. Basically, you need to simplify this fraction. When you add algebraic fraction, you need common denominator. As you have linear denominators here, the common denominator should be x plus 2 times x minus 4. I'm going to times this fraction by x minus 4, denominator and numerator. I'm going to times this fraction, denominator by x plus 2, do the same thing to numerator. You can expand this bracket. That would give you x square minus 4x over denominator, plus you can expand this bracket here, 2x square plus 4x. Now you have common denominator, therefore you can add these two expressions together. Denominator is x plus 2 times x minus 4. You can simplify the numerator. You can see this minus 4x cancel out to plus 4x. You can add x square and 2x square together. That gives us the simplest form, 3x square over x plus 2 times x minus 4. Part B, they ask you to expand and simplify these triple brackets. Let's see how you can do this. Keep this x minus 3 outside and expand this double bracket first. Times 2x by 4x, 8x square, and times 2x by plus 5, 10x, 3 by 4x, that's 12x, 3 by plus 5, plus 15. Simplify this bracket. You can add 10x and 12x. Now you can expand these two brackets. First times each of these terms by plus x. 8 square times x is 8x cubed. 22x times x, 22x square. 15 times x plus 15x. Now you can times each of these terms by minus 3. Minus 3 times 8x square minus 24x square. Minus 3 times 22x, that's minus 66x. Minus 3 times plus 15, that's minus 45. You can simplify this expression by collecting like terms. We have 8x cubed. You can simplify 22x square and minus 24x square. That's minus 2x square. Plus 15x and minus 66x. That's minus 51x. We have constant here, minus 45. This is the expansion of these triple brackets. Here you have a very nice question. Read the question carefully and get all the information given. What they say is, Carlo puts tin into small boxes and into large boxes. He puts 6 tins into each small box and 20 tins into each large box. Carlo wants to put 3000 tins into smaller boxes and large boxes. In the ratio number of tins in small boxes to number of tins in large boxes 2 to 3. And Carlo says that less than 30% of boxes filled with tins are large boxes. You need to decide whether Carlo is correct or not. You must show your working. Let's see how you can do this. To decide whether Carlo is correct or not, you have to find the percentage of large boxes. To find that percentage, you need to know how many small boxes he used. If you know these two, you can work out percentage of how many large boxes he used. That's equal to number of large boxes divided by total number of boxes. You need to times this by 100%. Now let's see how we can work out these two. You have total number of 3000 tins. You can use this piece of information to work out number of small tins and number of large tins. Using this ratio, you can work out how many tins going in small boxes and how many tins going in large boxes. As we know this ratio is as 2 to 3, we can write this as a fraction, that is 2 over 5. And this we can write as a fraction, that is 3 over 5. If you times these two fractions by total number of tins, you can work out tins in small boxes and tins in large boxes. You can work out these numbers. 2 times 600, 1200. 3 times 600 is 1800. That means 1200 tins going in small boxes and 1800 tins going in large boxes. As we know, he put 6 tins into each small boxes. We can work out how many small boxes he used. That is 1200 divided by 6. That's 200. And he puts 20 tins into each large box. Therefore, we can work out how many large boxes he used. That is 1800 over 20. This is equal to 90. So you can work out percentage of large boxes he used. Number of large boxes he used is 90. Total number of boxes 200 plus 90, that's 290. We have to times this by 100%. You can use the calculator to work out this. You would get 31.03%. Therefore, you can write that Carlo is not right. I have also made lessons for A levels. Check them out on my channel. To continue with the series, check the next video. See you in the next one.